Hey everybody, this is Larry. This is day 26 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. 1289 minimum flowing path sum 2. Yeah, alright, let's take a look. I ran like 8 miles today just to kind of get warmed up for my half marathon on Sunday. Wish me good luck. For the people who had comment on my yesterday's video, thank you. And if you haven't heard, I last minute signed up for half marathon for in 2 days or 3 days or whatever it is on Sunday. So definitely, if you're a runner, give me some tips, and if not, then give me some love and support. I'm really excited, actually, to be honest. I've never ran in a race before, so yeah. Hopefully, I'll have a chance to run in a marathon one of these days, but half will be fun. All right, let's take a look at today's problem, minimum flowing path sum, and this one, one element from each row such that I think, yeah, that's what I thought. There are a couple of versions of this, but I think the interesting thing that I wanted to point out about this particular problem is that okay, and it's 200 is a little bit weird, but is that let me pull it up real quick. Actually, I guess I could just pull it from here. This was if you look at the contest, if you look at the this way, right? I don't know. The happy lead coding, if you click on it, you get 10 lead coins. But I'm pulling here because it is true, right? That was like the Q3 of the contest. And I was talking about this during the contest, or not during the contest, but like after the contest in the review video, I talked about how this is similar to another problem. Yeah, because basically in every row you just cannot have adjacent same number. Here, it's the same idea except for that it is the column, right? So it's not quite the same, but it has a very similar idea that you get basically for each row you get the how do I say this? So basically, you can there are a couple of ways you can do it. The naive way, or not, it's not naive, but the basic way about dynamic programming is just that the basic dynamic programming is having the state of each row, which makes sense because you have to do it row by row, and then each cell, given that the previous cell or gives each cell or each cell in the row that denotes the minimum sum of the flowing path ending in this node, right? So basically, maybe you create a dp sub ij where given the ith row and the jth column or jth cell, maybe column cell, right? What is the minimum sum with all the constraints that they mentioned, right? Which is not having the same column. What is the minimum sum ending in this cell, right? And this is a very basic dynamic programming, and I don't mean to say it in a harsh way. Hopefully, yeah, I like definitely try to solve it in this way. And yeah, the problem with this is that given that n is 200, it's just a little bit too expensive, right? Because the way that this is going to happen is that, well, how many inputs are there to dpij, right? Well, there's going to be n squared in this case, right? Yeah, n squared, because apparently it's a square, right? So you have n squared, and for each cell, you have to minimize all the previous rows answers, right? And if you do a minimization on that, and if you do it naively, then it is going to be another n, because you have to look for 200 answers or n answers, and that's going to be n cubed. 200 cubed, it's going to be 800, which is 8 million, and 8 million is usually more than I would like. Sometimes it works, sometimes it doesn't. Leetcode is very random. That's why I cannot give you a more precise, like yes, no binary answer whether it's fast enough. the reason, and I talk about this from time to time, I don't want to spend too much time on that part, but the idea here is that Leetcode measure so the Leetcode judge does not know how your code does anything, right? It just kind of runs your code, and then if it's fast enough within some timing differences, like it gives you 10 seconds in Python, if it runs within 10 seconds, it's good. If it wants it below 10 seconds, it's bad. But as a result, sometimes you may have a good complexity, but your constant is high, and it may go too slow. Or if you have a high complexity, but the constants are low, then maybe it passes, right? So then you have this false positive, false negative thing sometimes, right? So how other people, or how a lot of other judges do it, is that they basically tune it so that, say for example, if they want the solution to be n squared, then all the n squared solution should pass and all the n cubed solution should fail. Then they tweak the, like instead of 10 seconds, maybe they do 5 seconds so that n cubed will fail and stuff like this. They do a lot of testing. The problem with Leetcode is that they do this thing called the sum of execution time, because on not all the other judges, but many of the good judges, they basically judge it by per example, right? They tell you all these inputs, so then they only want one input. One input has one time constraint, and if they have 100 tests, then it would have 100 different. It have 100 same time constraint, but it would run them each with its own clock, if you will, right? On Leetcode, it probably for, I want to say, architectural design reasons, for simplicity, this is easier to implement. And in the beginning, probably you just don't think about it. And now it's too late. But it's too late if you don't want to spend money. But as a result, it takes the sum of execution time, meaning that, let's say you have 10 seconds, it doesn't matter it's 10 seconds independent of whether they have 10 test cases or 100 test cases. And because they don't tell you how many test cases there are, there's no way to know. So we're 8 million. So this is a long way of saying n cubed is 8 million, and 8 million would be fast enough for 10 seconds. But if they have, say, 100 of these test cases, and there's no way for me to know because they just don't publish the test cases, then you're just out of luck. Anyway, I will write it out. Give me a second. Let me get a water real quick. A little bit. Gotta stay hydrated. I'm a little bit thirsty these days, and I don't mean it in a I don't know how the kids mean it this day. I'm just literally need to be more hydrated. Anyway, I will write it out though, however, and I am going to write this out bottoms up or tabulation. I'm not going to write it top down for a reason that hopefully we'll see in a second, right? So okay, so DP we'll write it out. Minimum, so we could just do infinity, right? Time, I guess n. Usually for grids, I like using R and C for the obvious reason of row and column, so it's harder to confuse. Otherwise, back in the day I used to confuse it a lot. But this is a square grid, so n is fine too, right? Yeah, and then infinity is you go 10 times 20. And then now, the first row, we can just say dp sub 0 sub I is equal to grid sub I, right? Oh, 0 sub I, sorry. Oops. Because that's just, you have no sum, that's fine. You can also add a different base case if you really like. Like maybe you could have a 0th row that is all zeros and then kind of build it that way. There are different ways of building up the base case. I'm going to do it this way. And then now, though maybe for consistency's sake, just for reading, I'll keep it as a J because it is on the J column. Or J is the column just by my current notation. And then now, for each cell, okay, so then now dp sub ij is equal to min of dp sub ij of all the previous columns that is in the same column, right? So maybe I would write something like this, right? So dp of I minus 1 k plus grid of ends here, so ij, right? But it has to be that j is not equal to k, right? And then now at the end, we just return min of the last row because that's the row that we care about, right? And yeah, and that should be mostly good, fast enough for the example cases. But again, for the n is equal to 200, I have some doubts, right? So, okay, so now we have a dynamic programming is n cubed. It's not fast enough. Do I want to submit it just to show a point? No, it's fine. When did I do this anyway? 2019. Wow. Wowie, wow, wow, wow. All right, let's give it a submit, and then we'll see if it's fast enough. I don't know if it's fast enough, but it's okay. We have an idea. That is actually surprising. All right. Well, that is not the intended solution, I don't think. Still. But it's fine. Whether that's the intended solution or not, that's fine. We'll do a better one. Hang on. I actually thought it was going to time out. But okay. So now you have this, then what happens? Well, one thing that you can do, right, is that, okay, what does this formula look like? Well, you know that this doesn't change, right? So that means that we can remove this and then maybe save it up for later, right? Like maybe, I don't know, dpij here, right? And maybe here it's a little bit awkward, but I think it starts out in infinity anyway, right? So this should be good. Let me double check. Yeah, I'm not gonna submit it this time, but you can kind of just take it out of the minimization loop, because if you minimize over every number that adds the same constant, or in the constant in the min loop, which is what the k loop is, then we can take it out, right? Okay, so then now we have this. Well, what does this do? This is basically saying minimizes dp sub I minus 1, the entire row, as long as j is not equal to k, right? I mean, I'm basically writing, like, without proper context, you don't get this comment. You'll be like, Larry, this is a useless comment. Why do you even use this? You know, like, it's a waste of our time to even look at this comment, right? Well, now we can do something about it, right? Because then now maybe we can structure the previous row such that this is easy to follow. Well, how would you write, you know, maybe a naive way of writing it, right? Well, okay, let's say we have dp sub I, right? Okay. And maybe one way that you can think about it is that we can just sort it, right? If we sort it, then if we sort it, then we're able to have a structure that we can manipulate. Maybe you can even be a little bit faster than me if you like, right? Let's say we sort this, right? And then what happens? Then now this function, if we try to minimize this function after, if we try to minimize this effectively after sorting, what does that mean? Well, it's just this first element, right? So then now we're done, right? Almost. Well, not exactly, because of the j is not equal to k. Because, well, if k is equal to j, then you can't do it. But there is the pigeonhole principle. Because basically, what does this mean? Let's say we sort this and we look at the first index. What does that mean? I mean, maybe we can write it in a more complicated way, right? Maybe like, maybe we can write something like, you know, for k in range of n, right? Let's just, for purpose sake, we rewrite this as equal to this with k. So then now we return it with a tuple, and then now we sort it. This is very Pythonic, and it's not real code anyway, so hopefully it don't matter. But the point is that now this will give us the smallest value and the index, right? And what does that mean? That means that now the index of the smallest value. And it turns out, of course, that if we look really closely and think about the j is not equal k constraint, there's only one case where this is true, right? So that means that if you also keep track of I minus 1, that means that, okay, let's say yeah. Then now, and let's say we call let's call the smallest index I don't know, min k, right? So then now we know that here in this for loop, how do I write it? I can now write it as dp sub ij is equal to min of all this stuff. Oops. I mean, I'm writing, this is like pseudocode, so please bear with me. Right, so now I could write it like this, unless it is equal to min index, right? Let's say, I mean, we'll clean this up, we'll write it correctly, but I just want to kind of work through this idea with those people at home. People tell me that I don't visualize it enough, so then if min k is not equal to j, then now we can just min all these things because this j is not going to be equal to the min of this, which of course, as we said, I wrote this as a min, but it's just going to be 0. Else dp sub ij is equal to dp sub I minus 1 of 1, right? Because that means that min k is equal to j. So we just get the second smallest value, and this will be good enough. And of course, at the end, you add it to the grid. And that's pretty much the idea, really. We have to clean this up a little bit. But now, let's say we did it this way. Then what's the complexity? It's going to be only n squared, because you only have to save 2 things. And that's pretty much it. So yeah. So let me rewrite this now. Now, instead of n by n, now we can have n by 2, say, right? Yeah, maybe, I don't know. Maybe I could just do 2 something like this, if I wanted to add a dimension, right? Is that right? I think this is, no, times 2. Okay, there we go, maybe, I think. I don't know how to do dimensions, apparently. All right, let me just write it from scratch. I think I got confused. So times 2, right? And then this, n, right? And then now this for. I feel like I messed this up because now I have 4 brackets. I think this one doesn't need one, but that's why. All right, fine. All right, let's just print dp real quick. Because apparently Larry doesn't know how to write. Okay, that looks good enough. It looks like it doesn't give me an error, is what I mean. Okay, yeah. And then now, so you can write it this way for sure. Why did I write it this way? Yeah, I think I'm just confusing myself. I think that's the problem. All right. Instead of writing this dp, we don't even need it, right? We can write 2 things, right? Which is previous min is equal to, say, infinity. Previous min index, which is what we had anyway, or wanted to write. It doesn't matter. We can set it as none. And then previous min, second min, so maybe 2. I don't know if that's clear, but index, mine index, 2 index is equal to none, right? So we can write something like this, and then now we can set the base case. We could convert this very quickly, right? Yeah, I mean, this is technically you're supposed to set the current, but I think that's fine. And then you set the current as equal to previous, so maybe that's fine. I don't know, but yeah. And now, yeah. So if grid sub 0 sub j, and now this is the base case. If this is greater than or less than previous min, then now previous min is equal to grid of oj, kind of. We'll have to do it with index is equal to j, right? Something like this, right? But it's not done because now what happens to the previous min? Well, now the previous min goes to the previous min too, right? So we can do something like this. Yeah, something like this. And then now else if this value is less than previous min 2, then now you can write previous min 2 is equal to grids of O of j, and then previous min index 2 is equal to j, right? So pretty basic stuff. So now, I mean, maybe not, I don't know. Let me know in the comments. But basically now we just keep track of the minimum item for the previous 2 rows. That's basically the idea. And then here, now we do the same thing, right? Now we just do it row by row, right? Except for now we want current min is equal to infinity, right? Same thing, right? And then now for each item we can basically do this. So okay, so then now for each cell we go, okay, so if j is equal to the previous min index, then now that means that the current value is equal to grid of ij plus, because this is equal to the min index, we now have to take it from min 2, right? And by definition, j is not going to be equal to the previous min index 2, right? Because it can only be equal to one of them by definition. I have to double, I mean, I guess they give you an n is equal to 1 case. I think that's the one case that I might have to be careful about, but it should be fine, right? And then else j is not equal to the previous min index, so current value is equal to grid of ij plus previous min 1, right? And that's pretty much it. That's all the idea. And like we said, maybe we can take this out even if you like. And then now current value, was it ij? And then now we compare the current value with the mins, right? So same kind of structure here, really, though it's just very messy looking. Yeah. Current value is less than previous min. Oh yeah, we have to do the shift thing, right? Oh, it's current. Sorry, man, I'm confusing things in my head. But that's okay. Maybe, I don't know. I have a big head. Do I have a big head? Let me know in the comments. I don't know. It doesn't matter. My big ginormous head. Okay. Oh, current min is equal to current value, and then now current min index is equal to j, right? And then else if, oops, keeping in mind that the else if and the order does matter in this case, because if current value is greater than current min, then this is this. Should be okay. Yeah, I think for pigeonhole principle it should be okay. So the one case that I did actually forget to think about, even though it should be okay, is the Leetcode case. If it's Leetcode, it's fine. Then if it's not here, then it'll either, if it's just for tie-breaking purposes. For in this case, there's no tie-breaking purposes, and because of pigeonhole, it has to fall into one of these two anyway. So it shouldn't matter. Oh, it's 2 index, isn't it? Not index 2. Oh, that's fine. Here I got it wrong though, I think. That's what I was looking at. J, right? And that's pretty much it. And then at the end, we want to update previous to these things, right? I mean, assuming that I know how to spell it correctly. And then at the very end, we can just return previous min. Looks good. Let's give it a submit. Hopefully we didn't make a silly mistake. And there you go. As you can see, it is way faster. I mean, and the reason is way faster, and I guess I didn't really go over it more specifically, but it also should be obvious, is that now this is n squared, right? The inner loop, I mean, the code is obviously much messier, but you get, and maybe there's a cleaner way of writing it, but now you see that the K loop, the extra O of N loop is now just if statements. So you get rid of it, and it's 200 times faster or whatever, for N is equal to 200 anyway. So O of N faster, N squared time, and still pretty good. Oh, and in terms of space, this is just O of 1, right? Because now we only have 4 variables here, 4 more here, so a constant number of variables, so it's O of 1, which technically speaking, it is space optimized. It is still the same idea, but space optimized. So yeah, and you could write out the DP if you like, but I'm a little bit lazy today. A little bit tired. I'm always tired. I don't know. Let me know what you think about this one. Yeah, that's all I have though. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.